All right. So welcome back, guys, to uh the to my YouTube channel, and we are going to continue working the 2022 past paper question that is for the Unit 2, Paper 2. All right. So we have looked at the first part of the question. So we want to look at the second part, part 2, and in essence, they want us to derive a formula, right, that we can use to find the total resistance when three resistors are in series. So prior to this video, we would have drawn a circuit with three resistors in series. And so therefore, they just want us now to come up with this simple formula. So because you know that when you have resistors in series, we can find the total resistance, yeah? So RT is equal to R1 plus R2 plus R3. In a sense, that's how you find the total resistance, by adding the resistance of each of the individual resistors. Now, for us to get to that equation, basically, it's a 6-mark question, so it's going to require a little bit of recalling. I don't think it really values 6 marks per se. However, let's just see. I mean, I think Cape this year didn't have enough questions, so they gave away marks per se. But first thing first, you need to recall that in series, the voltage is divided across the component. What that simply means is that whatsoever total voltage that is provided by the battery or the power source, right, that voltage will be divided among each of the resistors. Okay, so if we go back a bit here, you can see that each of these resistors will have an effective or a particular voltage based on the value of the resistance. Yes. So with that being said, we now need to make a recollection pertaining to what we know as it relates to Ohm's law, because Ohm's law, in a sense, ties in this formula that says voltage is equal to I. As a matter of fact, the total voltage provided by the power supply is equal to the total current, right? That we can consider that to be IT times RT, which is a total resistance. So if I want to find my total voltage, right, I need to know my total current in the circuit, and I also need to know the total resistance, right? So with that being said, and since current is constant or remains the same, in series, right, then therefore means that across all of the resistors, it will have the same current that is supplied by the power source. So with that being said, we can now make more of a simplified or substitution, in a sense, into this equation here. So rather than having VT, we're going to have I T times RT is equal to IT times R1 plus IT again, which is my total current, times R2 plus IT times R3. Now, since IT is the same right across the board, right, we could factor it out from the right side of the equation, and then you'd see that it will be easily cancelled out. So if we factor that out, right, we are now left with this And by just using a bit of mathematics, because we have similar things on both sides, we can get rid of it. So at the end of the day, we're now left with the formula that we use to find the total resistance in series. All right, so this is for series circuit. All right, guys, don't forget to comment, subscribe, hit the post notification bell, and of course, share the video. Tell a friend to tell a friend about this channel where we provide quality explanation surrounding different parts of your questions and physics concepts as you would imagine. All right, so that's it for this question. We'll stay tuned for the other questions to come.